I assembled the first one and I made some big mistakes. There's no real assembly instructions, which is the reason I really wanted to make this video, is to help other people. I'm YouTubing. It's kind of circumferentially surrounded and supported. Too bad my welding was not great also. A lot of people don't agree with me on this, but it's not necessarily pretty, but it's strong. What you should do, and then I'm also going to show you what I did and why you shouldn't do it. Hey everybody, what's up? On this week's episode of Chasing 518, I'm going to show you how not to screw up a trailing arm like I did. Stay tuned. This is a trailing arm kit this is the competition trailing arm from TMR Customs. And when you get it, you have your choice of adding tubing and 70-75 aluminum to the order, or you can supply your own. I've got the full kit from them, so it's 2-inch, 250 wall, 48 inches, plus 70-75 aluminum solid. Also comes with their side plates that are slotted for the corresponding tabs on the other pieces to ease assembly. And it's got their signature side plate with their logo cut into it. Uniball cup also comes with the uniball and the anti-wobble assembly that gets pressed in after you're all done welding. I assembled the first one and I made some big mistakes. So now I'm gonna assemble the second one on video, and I'm gonna show you guys what you should do, and then I'm also going to show you what I did and why you shouldn't do it. So let's get started. First thing we're going to do is we're going to notch the end of the 2-inch 250 wall for our uniball cup, which will go right here on the end of the tubing. The first thing you need to figure out when you're going to build these trailing arms is how long you need them to be. Now, what I had previously done on my car was I had just used some old galvanized pipe that I could find from my neighbor, and I simulated all of the suspension, and I got all of my geometry figured out the way I wanted, and determined that the length of my trailing arms was going to be 40.5 inches. So these arms come out of the box. If you use them, the side plates as cut, they're made to build a 48-inch trailing arm, but they can be trimmed down, and I'm going to show you how to do that. The first thing you need to do is notch the 2-inch 250 wall. And the first thing I learned was that the way it's designed with the side plates, that's a good representation of the offset that you're looking for that notch. That's how the side plates are designed to work. I went ahead and set up my notcher to cut clean with the bottom of the tubing and give me that kind of offset notch. So let's go ahead and get a notch cut in this, and then we'll determine overall length, and I'll trim my excess from the other side. Now that the tube's notched up, I'm going to go ahead and take a flap disc to it, clean it up, bevel the edges, get it all prepped to be welded to that uniball cup. Okay, now that we've got the tube notched, cleaned up, we can mate it with the uniball cup here. And we need to establish an overall length that we need. Now for this one, I can just cheat and I can measure, the one I made back to the tubing. It looks like I cut it at like right there. If you didn't know the length you needed, what you'd want to do if you knew your mounting points is you'd want to thread your rod end in, slide it into the end of the tube, figure out your eye-to-eye measurement, and then cut it to give yourself a range of adjustment in your tube coupler or tube nut. So all I'm going to do right now is just copy the length of the other one, and then I'm going to put it in my chop saw, cut it to length, and then I'm going to go ahead and strip all this coating that comes on the tube off to hopefully get a cleaner weld product. It's probably the first thing I didn't do when making that one. I struggled with weld spatter across the whole thing. You know, I'm always trying to learn to weld better. I don't really weld good at all. And one of the criticisms or suggestions I got was that I should probably prep the material better, you know, and basically get it clean like this thing. So I'm gonna try and take the coating off this whole thing once I cut it to length. Okay, now that we got the tube all cleaned up, I'm gonna go ahead and just tack weld the uniball cup onto it, and I'll check for squareness, and then we'll measure for our 70-75. All right, that looks good. So now what we need to do is figure out how much of the 70-75 we need. Let me clean this off real quick. So we'll just simply slide it inside. Take our tube nut, our tube insert, we'll mark where it sits on the aluminum. And just bring it out, transfer that mark. So now if we cut it, cut it right there, that should give us the correct installed length. With the 70-75 cut to length, now I want to go ahead and drill some holes in the DOM for plug welds to help attach my tube insert. So I'm going to go ahead and mark the depth for that. Take this over to the drill press, and I'm just going to drill a 1/2 inch hole all the way through it. Take some acetone and clean everything up, and then we can go ahead and put it together for weld. So now that we've got tube nut in, the uniball cup tacked on, I'm going to go ahead and weld these sections together, and then we'll get ready for all the plate structure. Let's talk about the welding procedure for the uniball cup. The shell, although strong and like a 1/4 inch thick, is going to distort heavily when you weld on it. So a lot of people suggest coming up with some sort of slug. Ideally, this would be solid brass or bronze, whatever this is, to better resist distortion and absorb heat evenly out of it. But this is all I had. It was a little bigger diameter, so I was able to turn it down and get it to be a nice good slip fit. So I'll leave that in for welding the whole time. And then on the rod end side, I shouldn't say nobody, a lot of people don't agree with me on this, but I've had good luck using high temp anti-seize, the copper, on a rod end, obviously a liberal amount. I thread it in, and then I weld the whole thing up with this in it. So it kind of acts like a heat sink, but then this keeps it from sticking or galling, or kind of, you know, welding itself to it. So once I'm done welding, then I thread this out. I've been sanding all the pieces and getting them cleaned up. I soak anything with mill scale, I soak it in a kind of 50-50 mix of muriatic acid and vinegar. These are too big for my little soak bucket, so I kind of brushed it on, left it for a while, but I'm gonna have to go ahead and sand the remaining residue off. So the next step's gonna be I made a template of the end, because that's the profile that fits on the uniball cup, and then figure out how much you're shortening them up. And then I just went ahead and traced it back here. That way when you're done, they lay on the cup at the right length. So now that I've got that marked out, I'm gonna cut them in the bandsaw, and then I'm gonna sand these two pieces down, get all the mill scale off, get the rest of the pieces all cleaned up, and get it kind of bolted together and clamped, and start getting it ready for weld. Now that all the pieces are cleaned and ready to be welded, I'm going to go ahead and assemble the truss structure and then set it on the link and see if I can clamp it and position it for welding. It takes a little bit of figuring out which pieces go where, but it really only fits one way. I made these spacers a while ago. This is the width of a shock plus like 35 thousandths, and they were meant to be mock-up spacers, so if I was ever welding like shock tabs or something, they would give me a little bit of room so the shock would slide right in later. However, with all of the welding inside of these pockets, once I put these in and welded everything, I couldn't get them out. It had closed so much on me, so I actually had to spread them back out and get these to go back in like this. What I want to try on this one is do the spacer plus a washer, and that way when it shrinks from all the welding, that hopefully once I get it out, it'll be the right width. It'll be this width. Alright, so just got everything snug. See if we can put it on the arm. Check the fitment. Oh, it's good right there. That looks really good. So now I'll throw it in time lapse, and I'll just start adding a bunch of clamps and get it square. I'll check the plane of this uniball cup to the plane of these plates, and just make sure it's not clocked wrong. And then once I get that, I'll just start adding a couple of tacks. Okay, now that I've got a couple well-placed tacks, I'm gonna clean off the workbench and get it here in front of me and get comfortable. I'm gonna take some soapstone, and I'm actually gonna mark out distances across it and try to put the welds in sequentially, skipping around, moving the heat, and also weld even distances so that hopefully the finished product looks a little bit more uniform, since you're not gonna weld continuous because you don't wanna put that much heat in it and warp it like I did the first one. Get cleaned up and get it all laid out here. All right, fast forward several hours. So I think you saw I had marked it out every 5 inches with soapstone. Then I just alternated those welds until I got all the way around the thing, and it took me pretty much all day. So I time-lapsed some of that for you and saved you the boring part. Now that it's all welded and cooled off, I need to wrap the extra material around the uniball cup. That way you're not relying on just the butt weld holding the cup to the tube and the plate, but it's kind of circumferentially surrounded and supported. It's not part of their design, but because I shortened them, I have the extra material to do it. So I could have either just cut it off and welded it on. I'm sure it would have been fine, but I figured why not just give that thing a wrap, almost like the front of a leaf spring has a full wrap. So it's all welded. Let me show you how much. I talked about spacing those shocks out. In the shock mounting location, I had a spacer and a washer. Now let me show you how little room we have. Like, that's how tight it is now. So that one's even tighter. So running a washer in there was definitely the way to go, because now you can still put a shock in there and then get a bolt in, and then when you tighten it, it'll squeeze it a little bit. So the only welding I have left to do, shouldn't say only. So I need to get this wrapped around and welded, and then I still have the detail plates to go on the outside. So I gotta put those on. And obviously there's a lot of welding around all the shape of them. I'll get those on and get the camera set up for you guys. Can you what?
Can I go away?
You don't have to go away, but I need to finish this heating and hammering sequence.
Fine, how long will it take you?
I don't know, a couple minutes.
Okay, good night. I'll be in soon.
All right, I got a little bit ahead of myself, but let's talk about the last step. So the last step is to put these overlay plates on. So I went ahead and just pulled the bolts back out, ran the bolts through it. They kind of act as a weld washer, and then also one more piece of gusseting where you're hollow through here. I marked out equal distances around it, and then I tack welded those. I had to clamp the ends just because it was trying to gap it a little bit. So now I'm just gonna evenly move around and get them all welded up. This has been a really good project for me to practice my welding too, because I'm not any good. Considering that trailing arms are a expendable or consumable item on a race car, I figure, what better than to get a lot of trigger time on something that I'm gonna end up throwing in the trash in like a year or two anyway. It's been a great experience so far. We're almost wrapped up. Let's get to welding. Through the magic of video, we've fast forwarded a bit. Now we've got a fully welded arm here. It's not necessarily pretty, but it's strong. So now I'm gonna go ahead and knock all the weld spatter off, grind all the sharp edges, get the thing just fully cleaned up and ready for paint. I'll probably press the uniball in before I paint it, just to make sure I didn't distort that cup too bad. I think we're done. I'll show you a finished product when I have it. Okay. Both arms fully welded. Probably took me 3 days to assemble, weld, clean up, paint. I've got both arms completely done. The arms and the design and the engineering is great. The fitment of all the plate was great. It's too bad my welding was not great also. I learned a lot along the way of the process. They don't look amazing because my welding is no good, but the design of these arms is great. Super strong capture between the tube and the plate and the overlay on the uniball cup. The strength and gusseting of the shock pockets is great. There's no real assembly instructions, which is the reason I really wanted to make this video, is to help other people. I ended up drilling drain holes in the shock pockets because I've learned from previous experience with stuff like this that, you know, water and dirt get trapped in there and it just makes it hard to clean out. So I went ahead after I welded and I just drilled holes on both sides to create drains. Really captures the tube nut really well. Again, this whole thing is slugged with a piece of 7075 aluminum. Super strong. You've got 1/4 inch plus 1/4 inch, so you've got really good plate overlays here. The overlay plates are really nice. They give you really good double shear. That's a ton of thickness in there to prevent the bolts from ovaling the holes out. I have no doubt that these are gonna, you know, be really strong in the car. Confession time. I didn't know how much of this I wanted to share or talk about, but I feel it's really important if I'm providing an instructional video to show you and tell you what I screwed up. So when I welded all of the truss work on top, I did it too fast and didn't let it cool down enough. And these trailing arms actually now have a bow to them. I think I have a picture of them with a straight edge up against them that I can insert here. But they have a little bit of an uphill curve to them. That probably shows it pretty good, actually. That's not going to affect them structurally in any way. It's just an aesthetic. And again, I mentioned that, you know, these are consumable. So I think I learned and I kind of messed these up. And, you know, hopefully that's something I can get right on the next set when these are beat up and bent from racing. But I wanted to share that with you guys so that you don't make the same mistake I did. So weld slowly, let it cool down between welds. Probably cool to the touch is probably the way to do it. I just got really impatient and I just kept welding and welding and welding and thought that by jumping around, there's no way that all this 250 wall tube with 7075 inside of it and this 1/4 inch plate standing on end would bend, but it certainly did. So weld a lot slower than I did. Another suggestion someone had was maybe you tack weld the truss assembly together, remove it from the tube, and then weld the truss together, and then put it back on the tube and weld it to the tube. I don't know if that would work any better or not, but it's something to consider. So there you go. There's my advice and there's my video. I hope you enjoyed this video. I hope it helped you learn something from my mistakes. And if you choose to either build your own set of trailing arms from scratch or buy the TMR kit like I did, that you end up with a successful product. So thanks for watching. Like, comment, subscribe. If you know how to make my welding better, let me know. And see you guys next time. Thanks, everybody.